Hello everyone, I am Professor Anish Suwara and I welcome you all in this video lecture. In this video lecture, we will study about one of the combinational logic circuit, and that is multiplexer. Multiplexer is one of the combinational logic circuit which is having multiple inputs but only one output. Sometimes it is known as a data selector because at the input side we have various data input line, and any one single input data line is activated at a time and the data is transferred to output. So it is known as many to one. We have many inputs but only one output. We have n number of input lines and we have only one output signal. We have control signal, or it is known as a select line. We have number of m select lines. Now we have relationship between control signals, that is our select line, and input data line. Suppose we have n number of input lines, then select lines are required, that is 2 raised to power m. For example, if we require 8 input lines, then 2 raised to power 3, we require 3 numbers of select line. If input data lines are 4, then select lines, that is 2 raised to power 2. So 2 select lines are required. Now let us start with a general block diagram of the multiplexer. We have input data line D0, D1, and we have various input data lines Dn-1. So total we have n number of input data lines and only one output signal, and that is known as a Y. So data available at the input signal, at a time only one input data is transferred to the output. As we discussed earlier, that it is known as many to one. So we have number of inputs and we have only one output. And the data selection that is done by the control signal, and we have S0, S1, M-1. So we have m number of data select line, and based on the combination of the data select line, any one input data is transferred to output. Now for example, let us consider 2 to 1 multiplexer. Meaning is we have 2 input lines and we have one output line. Because we have 2 input line, so control signal or select lines are required, that is 2 raised to power 1. So only one select line is required. So we have a block diagram of 2 to 1 multiplexer. We have 2 input data lines, that is D0 and D1, and we have one output line, and that is known as a Y. And as we discussed, we require select line S, and only one select line is required for 2 to 1 multiplexer. So we have only 2 possibilities. Either S is equal to 0 or S is equal to 1. And accordingly, in each condition, input data D0 or D1 will be transferred to output. Now let us simulate the circuit and then it will be very clear to you. We have S is equal to 0. So D0 input data is transferred to output. So why now it is equal to D0 when S is equal to 0. Now let us simulate S is equal to 1. Then input data D1 will be transferred to output, and now Y is equal to D1 when S is equal to 1. So this way we can simulate the 2 to 1 multiplexer, and we can easily understand the operation of 2 to 1 multiplexer. Now based on this simulation, let us prepare a truth table. We have select line and we have output line. Select line we normally write as S and output, that is Y. Now we have two conditions for the select line because we have only one select line. Suppose S is equal to 0, then output Y is equal to D0. And when we select S is equal to 1, we have output Y, and that is D1. Now in both the condition, we are getting certain output. So when we prepare a Boolean function based on this truth table, we have to consider both the condition. So now let us prepare a Boolean function based on this truth table. We have two conditions, S is equal to 0 as well as S is equal to 1. When S is equal to 0, we write as S bar dot D0. So we require output Y is equal to D0 plus second condition, S is equal to 1. So S dot D1. So output Y will be D1. From the truth table, it is very easy to derive the Boolean function for both the condition. And based on this Boolean function, we can easily implement the logic circuit. We have Boolean function in SOP form. So we have two product terms. We require two AND gate. Because it is in SOP form, at the last stage, output stage, we require one OR gate for the summation of both the product term. We have input data select line S, and to get S bar, we require one NOT gate. So now let us implement the logic circuit. We require two AND gate for two product terms. We have select line S, and with the help of NOT gate, we can have S bar also. We have D0 in the AND gate with S bar, and we have D1 input to the AND gate with select signal S. So output of the AND gate we get, that is S dot D1 as well as S bar dot DO. At the last stage, we require OR gate, and output of OR gate, that is Y, and it is equal to S bar D0 plus S dot D1. So this way we can implement the logic circuit for the 2 to 1 multiplexer. Now let us take one more example for 4 to 1 multiplexer. Let us see the block diagram for 4 to 1 multiplexer. We have 4 input data lines, that is D0, D1, D2 and D3. We have one output Y, and as we have discussed earlier, in case of 4 input data line, the control signal or select line required, that is 2 raised to power 2, and that is equal to 4. So we require 2 select line for 4 to 1 multiplexer. So we have S0 and S1. Now based on the combination of S0 and S1, any one input data, either D0, D1, D2 or D3 will be transferred to output, and that is the function of multiplexer. So with 2 input signal at the select side, we have 4 different combinations is possible. That is 0, 0, 0, 1, 1, 0 and 1, 1. Now let us simulate the circuit and then it will be very easy to understand. So first condition 0, 0, output Y is equal to D0. Second condition 0, 1, now Y is equal to D1. At a time, only one data which is available at the input signal will be transferred to output based on the combination of the select line. We have third condition, that is 1, 0 and output Y is equal to D2. And last condition, that is 1, 1 and output Y is equal to D3. So this way we can see that based on the combination of S0 and S1, we have various output signal will be available and at a time only one data will be transferred to output. Now based on this simulation, we can easily prepare a truth table for 4-to-1 type of multiplexer. We have select input, that is S0 and S1, and we have output and that is Y. With two input select signal, we have 4 different combinations are possible, that is 0, 0, 0, 1, 1, 0 and 1, 1. And accordingly in each combination the output available, that is Y, D0, D1, D2 and D3. Now based on this truth table we can prepare a logic function. So we have logic function Y is equal to D0 dot S0 bar dot S1 bar, that is our first condition, plus D1 S0 bar dot S1, that is second condition, plus D2 dot S0 dot S1 bar, and that is our third condition, plus D3 dot S0 dot S1, and that is our last condition. So based on the truth table we have derived a logic function, and now from the logic function we can easily implement the logic circuit with the help of basic gates. We have 4 product terms. In each product term we have 3 literals, so we require 4 AND gate. Each AND gate will be having 3 input, and at the last stage, because the function is in SOP form, we require OR gate, and we have 4 product terms. So the OR gate required will be having 4 inputs. To get select line inverted S0 bar and S1 bar, we require NOT gate. So now let us implement the logic circuit. We have one S0 data select line, we have S1, and with the help of NOT gate we can have S0 bar as well as S1 bar. We require 4 AND gate. Each AND gate will be having 3 input. So we connect D0, D1, D2 and D3 to each input of the AND gate. Now remaining 2 inputs of each AND gate will be connected with the select line as per the input combination, that is 0, 0, 0, 1, 1, 0 and 1, 1. So 0, 0, 0, 1, 1, 0 and 1, 1. At the output side, we require one OR gate. Output of each AND gate will be connected to the input of the OR gate. Because we have used 4 product terms and we have used 4 AND gate, the OR gate is with the 4 inputs. So output of AND gate, now it is connected to the input of the OR gate, and output of OR gate that gives us the final output signal. So this way we can implement logic circuit for 4 to 1 multiplexer. Thank you for watching my video. Keep watching. Thank you very much.